In this video, we're going to begin section 2.2 on equations of lines. So our goals are to review the different ways we can write the equation of a line, how we can find the slopes of parallel and perpendicular lines, and how we can find where two curves intersect. Okay, so I want to begin by reviewing the different ways we can write the equation of a line. Okay, so remember the slope of a line, which we call m, is the rise over run, or sometimes we can indicate that as like change in y over change in x. So this triangle symbol is delta, a Greek letter, and that means change in. So change in y over change in x. So there are three common forms for the equation of a line. The first is called slope-intercept form. This is usually the one that you would have seen the most in algebra before. And that says that y equals mx plus b. Y equals mx plus b. So in this form, m, of course, is the slope. M is the slope. And b, this is the y-intercept. Okay. So that is slope-intercept form. Okay, so next up, we have something called point-slope form. So with point-slope form, I want to show you where it comes from. Okay, so I want to show you where the formula comes from. I'm going to draw a picture for this. So I'll draw some axes, so y-axis and x-axis. And then I'm going to draw 2 points. So this first point, I'll call this one x1, comma, y1. And the second point, I'm going to call it x, comma, y. And I'll draw a line connecting those points. A line connecting those points. All right, line connecting those points. All right, so I'm going to begin by writing down the slope of this line. Okay, so the slope of this line, I'll call it m. If I use my slope formula, I do the change in y over change in x. So subtracting y values on top. Maybe I'll do y minus y1. Maybe I'll do it in that order. Doesn't really matter as long as I stay consistent on the bottom. So then I got to do x minus x1 on the bottom. Okay, all right. So now what I'm going to do is I'm going to get rid of this fraction by multiplying both sides by the denominator. So I'll multiply both sides by x minus x1, the denominator. So if I do that, it'll cancel on this side, that thing, and I'll be left with, let me switch the two sides. I will get y minus y1 equals m parentheses x minus x1, and that is point slope form. So I'm going to go ahead and write that below here. Point slope form looks like y minus y1 equals m parentheses x minus x1. So in this formula, m is still the slope, but x1 comma y1, that is a point on the line. In fact, it could be any point on the line. Okay, and point slope form is really powerful because usually in calculus, it's a lot more common to be given a point on the line than it is to be given the y-intercept. So usually setting up point slope form ends up being quicker than getting to y equals mx plus b form. Okay, all right, third form is something called standard form. And standard form for the equation of a line looks like some number a multiplying x, and then plus or minus, and then I could have some number b multiplying y, and then maybe there's some other number c, and this whole thing equals 0. So in this form, the a, the b, and the c, they are just reals. They are real numbers. All right, let's do an example. All right, so example 1, I want to write the equation of each line either in slope-intercept form or point-slope form. Part A says, I'm given m and I'm given b. Okay, so this one should be super quick. If I'm given both of those, let's use y equals mx plus b. So I'll get y equals 2x plus 3. And that's my equation. Cool. All right, that's a quick one. All right, part B, I got 3x plus 4y minus 5 equals 0. Okay, so this one is in standard form. Okay, so I'm going to try to isolate the y. If I isolate the y, I can get it in y equals mx plus b form. Okay, so let's move the other stuff over. I'll get 4y still over there. And then this will equal negative 3x plus 5. So now I divide the 4. So y equals negative 3x plus 5 divided by 4. And to make it look a bit more like my y equals mx plus b form, let's split up this fraction. So this becomes y equals, I could do the first term, the negative 3x divided by 4. So that'll give me negative 3/4 x. And then plus that second term, the 5 over 4. Right, so those are the same. So those are the same right there. All right. Okay, so that is, I've put this into slope-intercept form, y equals mx plus b form. That's fine. Okay, one more example, part C. This one tells me a slope and a point on the line. So for this one, let's practice using our point slope form. Y minus y1 equals m times x minus x1. Let's practice using this. Let's plug in for the values we know now. So y minus y1 is a y-coordinate of a point, and I know that's 5. That's the only point I have to work with. Equals, slope is 2, and then I'll get x minus the x value of that point, and the x value is negative 3. So x minus negative 3, I get a double negative. So maybe I'll put a parentheses here. Okay, but the double negative means, well, it's going to turn into a positive. These will turn into a positive. So I end up with y minus 5 equals 2, parentheses, x plus 3. And that is my equation in point slope form. And the problem said point slope form was absolutely okay. So it's fine to leave the answer like this in point slope form. If I wanted to put it in y equals mx plus b form, I would have to isolate the y. So if I wanted to do that, I'd get y minus 5. I could distribute the 2 to get 2x plus 6. And then if I added the 5 over, we would get y equals 2x plus 11. So if I did want to get that, it takes me a couple of extra steps, but I could do it.